Question 308. Find the intervals where the graph of f is both increasing and concave up. We know that the graph of f is increasing when f prime, which is the slope of tangent line, is positive, right? And the graph of f is concave up when f double prime, second derivative, is positive, right? And when second derivative is positive, we know that f prime is increasing, right? Remember, here we have f prime, right? F prime is increasing, then slope of tangent line, which is equal to f double prime, is positive. So far so good? Okay, so f prime is given right here, and we're gonna have to look for the intervals where f prime is positive and f prime is increasing, right? When f prime is increasing, f double prime is positive. So far so good? So here, f prime is positive if the graph is above the x-axis. So this interval right here, above the x-axis, and this interval right here from 5 to 7, right? That's where f prime is positive. So let me, with blue color, I'm gonna mark this region, these intervals where f prime is positive. Also, f prime has to increase, right? It has to increase. So this part right here, it is decreasing, increasing, decreasing, right? F prime is increasing in this interval, right? Oops. In this interval. So from 5 to 6, f prime is both positive and increasing, right? So the answer has to be x is between 5 and 6. Or in interval rotation, we can write from 5 to 6. These are our answers, right? Question 309. Find the intervals where the graph of f is both decreasing and concave down. The graph of f is decreasing when f prime, the slope of tangent line of the graph of f, is negative, right? And the graph of f is concave down when f double prime is negative, right? Okay, when f double prime is negative, we know that f prime is decreasing, right? Because the second derivative, this is the slope of tangent line to the graph of f prime, right? So f prime has to decrease so that f double prime is negative. So far so good? So we're gonna have to find the intervals where f prime is negative and also f prime has to decrease, right? Okay, here is the graph of f prime. F prime is negative if the graphs are below the x-axis. So from -1 to 2, right? From here to here. When x is 2, f prime is 0, not negative, right? So we have to exclude 2, okay? So -1 to 2 exclusive, and 2 to 5, it's negative, right? And any value is greater than 7, so it's negative. So far so good? Okay, it also has to decrease. So from -1 to 1, right? Decrease. Here, negative and decreasing. So this interval right here. Here, negative also decreasing. So 2 to 4, right? So from 2 to 4. Okay, negative also decreasing in this interval. Negative also decreasing, right? So in this interval. So the answer must be x must be between -1 and 1, right? -1 and 1, or 2 to 4, right? X is between 2 to 4, or we can have x greater than 7. In interval notation, we can write -1 to 1, or we use this, right? And 2 to 4, from 2 to 4, and greater than 7, that's from 7 to infinity. That's interval notations. Okay? Question 310. Find all values of x for which the function of f has a relative minimum. Alright, the graph of f has a relative minimum when the sign of f prime changes from negative to positive, right? Then what happens is that f decreases and then increases, right? So if we draw the number line right here, let's say this is a critical point A, and we will have a relative minimum at x equal a, right? Okay, so we have to look for x where the f prime changes its sign from negative to positive. Here we have f prime. This part right here, above the axis, that's where f prime is positive, right? So positive here, 0 here, so that's critical point of f. Negative, right? Negative, 0, another critical point, negative, right? Still negative, 0, critical point, positive, positive here, 0, that's critical point again, negative here, right? So we have, let's see, one x value here, one x value where the sign of f prime changes from negative to positive, negative to positive, negative, 0, positive, right? So the answer has to be x is equal to 5, and that's the only value of x where the graph of f has a relative minimum. Question 311. Find all values of x for which the function f has a point of inflection. Okay, the graph of f has a point of inflection whenever f double prime changes its sign from positive to negative or negative to positive, right? Let's say we have number line here. Okay. And we have two x values a and b. Suppose that f double prime is positive here, negative here, positive here. Then these two x values are the points where the graph of f has a point of inflections, right? Okay, here remember f double prime is positive when f prime is increasing, right? So here f prime, in this interval it increases. If f double prime is a negative, f prime decreases, right? So it decreases, right? So we know that at x equal a, we have point of inflection on the graph of f, right? But what happens to the f prime? What happens to f prime is that f prime increase then decrease. It has relative maximum at this point, right? Okay, let's say f double prime is negative here and positive here. Then what happens to f prime? It decreases and increases, right? It decreases and increases. So f prime has relative minimum at this point, right? Okay, so here we have f prime, right? The x values where f prime has a relative maximum or relative minimum, at that point we'll have point of inflection of f, because f double prime changes from positive to negative at this point and negative to positive at this point, right? So here the graph decreasing, increasing, well, we have a relative minimum here, right, at this x value. Relative maximum, increasing, decreasing at this point, right? Relative minimum, right? Relative maximum here, right? So we'll have 4 points of inflections of f at x equal to 1, 2, 4, and 6. All right? Question 327. Suppose the function f is continuous for all x and it is twice differentiable in the interval from 1 to 4. Okay, here we have a table with the f prime and f double prime. The question is, at what value of x is the graph of f have a relative maximum? Okay, the graph of f has a relative maximum when the sign of f prime changes from positive to negative, right? Here, in this interval, f prime is positive. In this interval, f prime is negative, right? So f prime has a relative maximum at x equal 1. Here, when we look at the value of f prime, its DNA does not exist, right? But the function is continuous, right? Then that means we do have relative maximum at x equal 1 even though f prime is undefined, because the sign changes from positive to negative. Okay? Let's draw the graph of f roughly. Here, when x is equal to 1, right here, f prime is a positive, so f is increasing. But when we look at f double prime, it's negative, right? It's concave down. So it'll increase like that, right? Now after 1, we have f prime negative here, right? And f double prime is positive. Decreasing, concave up, right? So decreasing, concave up, it'll be like that, right? So we do have relative maximum at this point, even though f prime is undefined. Okay? So all you have to look at is the sign of f prime. If f prime changes from positive to negative, and it is continuous at this point, then we do have a relative minimum at this point. Okay? So the answer has to be B. What about at x equal 3? F prime, the sign of f prime doesn't change, right? At x equal 3, so we do not have relative maximum at x equal 3, right? Question 328. We have the same table here with the f prime and f double prime. The question is, at what value of x is the graph of f have a point of inflection? Okay, f has a point of inflection when the second derivative changes its sign from positive to negative or negative to positive, right? So f double prime changes its sign from negative to positive at x equal 1. So we do have a point of inflection at x equal 1, right? Also, positive to negative. So we have another point of inflection at x equal 3, right? So the answer has to be D. Easy, right? Question 329. Which of the following could be the graph of f? For reference, the same function f was given from problems 327 to 329. So the function f was continuous for all x, and it is twice the differentiable functions in the interval from 1 to 4. So, since the graph of f is continuous for all x, d cannot be the answer, right? D is not continuous at x equal 1. Okay? So we eliminate D, and let's think about A, B, and C. Here, f prime is increasing in this interval from 0 to 1, and f double prime is negative, which means f must be concave down, right? So here, concave down, but this is concave up, right? This is also concave up, right? So we eliminate these two. The answer must be equal to A. But let's look at other intervals too. When x is equal to 1, it is not differentiable, right? F prime doesn't exist. So at this point right here, f prime doesn't exist. You know, f prime is negative from 1 to 3, has to decrease. The function f has to decrease. And f double prime is plus. F must be concave up, right? So decreasing, concave up. And at x equal 3, slope is 0. So slope here is 0. And what happens is that f double prime changes from the positive to negative, right? We must have point of inflection. Concave up, concave down, right? And f is decreasing since f prime is negative in this interval. Decreasing. Concave up, concave down, decreasing, decreasing. Right? So A must be the graph of f. Question 335. The graph of f double prime, the second derivative of f, is shown above. Well, actually the figure is right over here. What are all intervals on which the graph of a function f is concave down? As you might know already, f is concave down when f double prime is negative, right? So f is concave down when f double prime is negative. And we have the graph of f double prime here. It is negative when the graph is below the x-axis, right? So this interval right here and this interval right here, right? So the answer has to be from x is from negative 4 to 2 and when x is greater than 5. So the answer has to be D, right? Question 336. At what values of x is the graph of f have point of inflection? Here we have f double prime again. And as you know already, f has a point of inflection when it's a second derivative. F double prime changes from positive to negative or negative to positive, right? So here we have f double prime. If it is above x-axis, it's positive. So here positive, 0, negative, right? Negative. What is f double prime is, right? 0, positive, positive, 0, negative, right? So f double prime changes its sign from positive to negative at x equal negative 4 and changes from negative to positive at x equal 2, positive to negative at x equal 5. So we have 3 points of inflection. They're at x equal negative 4, 2, 5. So the answer has to be D, right?